So we're going to handle this episode in steps. We're going to try a new format here. The first thing we're going to be doing is adding the blinking animation to our blocky block character. You can see here it's a quick animation. Basically he just closes his eyes as a double blink. So how we're going to do that is, well, first thing we're going to edit the code to change the animation state. We've already left this in, so this is something we can do from the previous video. Once we've changed the animation state, we need to set the animation sprite. Then we'll have to check to see if we are at the end of that animation. If we are, well, then we just change back to the idle animation. The second objective of this video is going to be collisions. So right now our character can travel through our blocky block with no problem. What I want to have happen is once our blocky block hits the ground, we cannot move through them. So to do this, what we have to do is when our blocky block hits the floor, we're going to create a solid object. And now when our blocky block is going to retract, then we're going to destroy that object so our player can pass through. The next objective is going to be the pushback. So we're going to push the player back to the left and then up a little bit, just so we can give a knockback effect. Instead of damaging our player, we're just going to throw them out of the blocky block object. Maybe that's something we'll do in the future, but for right now, I think this is going to be fine. The next objective that I want to cover is going to be the particles. So whenever our blocky block object hits the ground, I want to have a particle system come up and just kind of have some dust particles and everything fly up out of the place. The final thing that we're going to do in this video is going to be the sound effects. So I've recorded a sound effect and we're just going to put that into the game. So the very first thing we're going to do is handle the animation, the blinking. So let's hit Control T and load up our blocky block enemy. Make sure we choose the object. And within the step event, we have two state machines. We have the regular state machine and then we have an animation state machine. If you look on the regular state machine, right here where we're determining whether or not we can blink, we left a little comment in there. And what we want to do is instead we want to say animation state is equal to the animation blocky block state dot blink. And now we're done with the regular state machine. We have to switch over to the animation state machine, and down here quite a piece down you can see that we've left a case for blinking. So like we said in a couple minutes ago, what we wanted to do was wanted to change the sprite index to SPR underscore blocky block blink, and our animation is also, our image is also animated, so we need to change the image speed. And now we have this code up here already in the look right and look left. We just have to change it a little bit, and we'll just add in some checks. So we'll say bigger or equals, and if you've forgotten what this means is we are checking the current frame of the sprite that we're on. We're seeing if it is bigger or equal to the maximum number of frames that our sprite can have. So let's make sure we make that change also on look left. And then I'm going to copy the if statement, scroll back down to the blinking, and right here I'll say if the current frame is bigger or equal to the maximum number of frames, that we have in our sprite, then all we want to do is change the animation state back to animation blocky state dot idle. Now let's save that and hit our run. And let's check out these guys here at the top. Let's see, that guy blinked and went back. So it seems to be working. We should be able to run over and he'll go back up. And at some point he will choose a blink. He just looked, so we know that everything's working. There we go. Okay, so let's close this and let's move on to step number 2. And step number 2 was the collision itself with the blocky block enemy here. So if we get rid of, we minimize our animation state, if we go to our state machine, the code that we're going to be looking for is going to be the code where our enemy detects the floor. So down here in falling, right here we have an if statement, and then we have a while which we are moving towards a solid object, and then once we've hit the solid object, we set the vertical speed to 0. So this means that we have hit the floor. So let's actually say have hit floor. So in here, this is where we want to create a solid object to make it so our player cannot pass. However, what we're going to need to do is in the create event, let's just do this at the bottom. Down here, we need to track track solid object, because we're going to be destroying this object or creating it on the fly. So we'll just say tracking solid ID equals no one, because we don't want to have it assigned to any instance when we first start. And in the step event right here, we'll say the tracking solid ID equals instance create layer, and we're going to create it at the current X position and the Y position of our blocky block. And the layer, just so we can see it, we'll set it on effects, and the object is going to be object solid. Now, you want to make sure that you have this layer in your room, and I'm just going to double check that I have it in there. And it is the first one, so we should be able to see it. However, there's one thing that is wrong here, and actually if we hit F5, you should be able to see it. Our sprites are 64 by 64, however, our solid object, looks like we got an error. Let's see, the solid object is not set before reading it. Okay, let's close that. And I believe that's because we're using the wrong thing. We need the capital S there. So let's change it to capital S, and you can see it went red. Okay, so let's hit F5 again. And like I was saying, our characters and our enemies are 64 by 64, except our solid object is 32 by 32. So when I go close, you can see the object is really hard to see. I'm not even sure if that really got, oh yeah, it totally got created. We can't see it because, let's actually come in here and let's check that it is visible. Now our whole area is going to be kind of pink here, but we should see that an object gets created here and it's super small. So what we want to do is scale that up, and once we scale it up, we're going to have to reposition it. So I'm going to uncheck visible and go back into our solid here, our tracking solid. So what I want to do is say the image X scale is equal to, and the image Y scale is going to be equal to. Now this will scale it up, and actually right here I will also say visible is true, just so we don't have to change all of the different objects. Now even though that has scaled it up, what's happening is it's going to be off-centered. So we're going to have to change the X and Y position. We're going to have to move it over just a bit. Now doing a quick little bit of math, you can see that if we load up any one of these sprites, let's just choose the idle sprite, the anchor is in the center. So to get in the center, we're going to have to add 32 pixels. We're going to have to add it for the top and the bottom. So we could just say X plus 32 and Y plus 32. And if we give that one more try, we should see that the pink object is created directly in the middle here. Oh, that is totally wrong. My mistake. It is a Y minus 32, and sorry, X minus 32, Y minus 32. So that will move it over to the left and up. Perfect. Now he is pink, and we cannot pass through. Now the second thing that we needed to do is when he is retracting, we're going to have to remove this solid object. So we'll get rid of that, and let's make sure that we go to the retracting state, which is down here, retracting. And all we need to do is, let's say, we'll do a check. We could say if the tracking solid object does not equal no one, meaning that we have a state, remove solid object. Then if we have an instance, what we want to do is we want to say instance destroy, and we'll pass in the ID of the instance we need to destroy. Now, if we wanted to, if this is going to be happening a lot, maybe what we want to do is instead of destroying the instance and creating the instance, maybe what you want to do is check to see if we have a solid object. If we have a solid object, then move it into the correct position, which is this here, and then you want to activate that solid object. And in the retracting, what you could do is you could deactivate this solid object. So instead of creating and destroying objects, you have one object that is created, and then it's just deactivated and reactivated as we go. So you can see that I can't pass, but as soon as he goes up, I can pass just fine. The other thing is, once we're on there, we can jump on top of them. So the next thing that I want to do is work on some pushback. If I get my guy to go in the middle, I can't really move. What I want to happen is a knockback effect, just so our character gets pushed out. So to do this, let's go and close our blocky block, and let's open up the the player object. In here, we're going to create a new event, and we'll go down to collision and say that they are going to collide with our blocky block enemy. Now, in the presentation at the start, I wanted to say that the enemy has to be falling, or the enemy also has to be waiting. So we can't basically be retracting and get hit by this blocky block character. Maybe that's something that you want to do, but we'll just use those two statements for now. So we know that we are colliding with the blocky block object right now. So what we need to do is we need a way to determine if we actually were hit or not. And we can do that by creating a local variable. We'll say var is, we'll say was underscore hit equals false. And now we'll do an if statement. We'll say if the other dot state is equal to the blocky block enemy state of falling, or the other dot state is equal to enemy blocky block state dot waiting. Is it waiting? Yeah, we'll state waiting. Then was underscore hit equals true. Now the reason that we're doing this is because the other is accessing the object that we are colliding with. So the other dot state is actually going to the enemy blocky block, and it is accessing the state variable which we made here. So that's why we have access to these things here for falling and waiting. And if we were hit, so if was hit is equal to true, we could say equal true, but we don't have to. We can keep it shorthand. So if we were hit, then what we want to do? Well, if our player comes on the blocky block here and he is on the right side, I want him to push backwards. If he is on the left side, I want him to be pushed obviously to the left. So let's actually make that happen. So we could say if the X position of our player, remember we are on the player object, if the X position is bigger than the other dot X, then what I want to do is I want to say X is going to equal plus equal, let's do 16. Otherwise, the X position of our player will be minus equal 16. That hopefully should get us out, because the next thing we need to do is also set the horizontal speed to be equal to plus 16. I guess it's not plus 16, it's just 16. And if we are on the left hand side, then we want to set the horizontal speed to minus 16. And finally, we want to give a push up, so we'll set the vertical speed to minus 12. Now let's see, that might not work, so let's give this a shot and clean up anything that we have. So we'll come in here and we get pushed back. Let's try again. Perfect, pushback. We may want to, I bet you I can probably get him stuck because we are only moving 16 pixels, and we know that to get to the middle of this enemy is 32 characters or 32 pixels. So there is a possibility of still getting stuck. The easy fix is, instead of moving 16 characters or 16 pixels out, you can just move 32 pixels to the left or the right. And it might seem like a large number of pixels, but we are really just putting the character right to the outside of the blocky block object. Alright, let's see, retracting, I should just fall through. Perfect. Okay, so that is done. The next thing I want to do is the particle effects. I'm going to create a new group underneath our sprites. Just in case we have more, I'll just call this particles. And I'm going to create a new sprite called SBR particle dust. And I'll say edit image, and we're going to import a strip image. Now this particle effect I made in a third-party software. I believe it's called Pixel FX Designer. It's pretty cool, you should check it out. I believe they have a demo. But bear with me here. I'm just going to import all the frames. I think there's 28 of them. That looks about right. And I'll just say convert, which will bring this in. And I can just say auto trim all frames. And the final thing I want to do is increase the speed of this animation and then just hit play so my animation window can get going here. And that is the dust particle here that we're going to be working with. So I'm going to set my anchor to somewhere in the bottom and make sure that my speed is at 60. Next thing I want to do is create an object because we're going to be creating a bunch of these particles. So I'll create a group, and then within that group I will create an object called object particle dust. And within this particle, I'm going to assign the sprite, and I'm going to have a create event, and I'm also going to have a step event. In the create event, we need to scale this dust particle up. If we take a look at it in our room, you can see that it is very tiny, and well, I guess that would be okay. So let's actually do a couple things. Let's say the image x scale is going to be a random number between 1 and 2, and we'll do the same with let's actually just set the y scale to keep it proportional to whatever the x scale is set to. So if this number happens to be 1.75, the y scale will also be 1.75. The next thing I want to do is make sure that my image alpha is equal to 0 because I do not want to show the dust particle right away. Now I'm only going to be doing vertical speed, so movement up and down, but you feel free to add in movement left and right. But I'll do vertical speed is going to be equal to a random range between -2 and 0. And for the step event, this one's pretty easy. All we need to do is we need to move the particle up, we need to fade the particle in, and then finally we just need to check to see what frame we're on, whether or not we need to destroy this object. So we can do that by saying the y position is going to be plus equal whatever our vertical speed is. Now remember that vertical speed is either -2 or -2 point something, -1 or 0, so it's going to either move up or stay stationary and let the animation handle it. The image alpha, I'm going to use a lerp command. So just say lerp the current image alpha value, make sure that it goes to 1, and I'll just do it every 0.1 every frame. So that will be, it'll fade in nicely, and once it hit 1, it's not going to go any further than that. And just like before, we need to check the current frame, and if the current frame is bigger or equal to the last frame, then we just destroy the instance. So we can use the image index. If the image index is bigger or equal to the image number, sorry about my typing here, -1, then what we want to do is say instance destroy. Okay, so we have everything we need to have the particle kind of fly off. The only thing that we need to do is create a script so when our blocky block here hits the floor, which we determined previously, then we can create a couple of particles. So let's actually create a script here. We'll do create script scr add particles. And I won't do all of the parameters here. I'll just explain them as we go, and I'll clean up the code for you to download later. So a couple things that we're going to need is we need the x position, which is the argument, sorry about that, the x position to spawn at, the y position to spawn at argument 1. Then we need the horizontal speed, or sorry, not speed, but horizontal range, which is going to be argument 2, and I'll just copy the word argument here. We need the vertical range, or argument 3, and then we need how many times we're going to spawn a particle. So let me kind of go through this as we code. Vr position x, vr position y. So we're going to repeat this code however many times. So if we pass in 5, it will loop through this 5 times, and we will set the position x to going to be whatever we pass in here. So if our x is going to be 32, then we're going to say plus a random range of whatever our horizontal range will be. So minus horizontal range to horizontal range. Now let me just do this with the Y position and make this a little bit bigger, and then I will definitely step through this so you don't get confused. Vertical range and vertical range. So in our code, let's go to our blocky block code here. When we hit the floor, we create a solid object, then we spawn particles. So when we hit our floor, what we want to do is spawn some particles. So we'll call our new script scr add particles, and in here, like I said, it's going to be the X and Y position to spawn our particles. So if we actually take a look at our sprite, the idle one, we know that the X and Y position is going to be here in the center. So we're going to have to move it down 32 pixels to be at the bottom. So let's do that first. So back in the blocky block, the X position is fine, but we're going to say Y plus 32. So once we have done that, the next one we're going to be using is the vertical and horizontal range. So what I'm doing here is I'm basically passing in a single number, so this could be 16, and whatever position the X at is going to take either minus 16 or plus 16 and get a random number between there and just add it on to that position. So instead of all of our particles spawning directly in one spot, it'll be over here or over here. It just kind of gives it a nice touch. So let's go back to our enemy blocky block, and the X position we could say is 64, and the Y range is actually going to be 0 because we don't want it to move up or down. And the number of particles that we want to have is 5. So let's save that, and I think that should work. X32, it looks right from here. Let's give it a try. And all right, let's try and have this guy fall down, see if any particles. You know what, particles are not going to happen because in our script I didn't actually create any particles. I set the position, but I didn't create any effects. So we'll say instance underscore create layer at the position X, position Y on the effects layer, and we want object underscore particle dust. And I have actually spelled that wrong, so let me fix that, and I'll also fix it here. We'll just bring this up and change the name. I think that's the only place I referenced it for now. So let's hit F5 and let's see if these dust items get created. Nice, so those were all the way over here. Let's make sure we get some other ones. So it seems to be working pretty good. Now the only problem with that is I'm getting them, even though this is not all the way across, it still happens. So maybe what you will want to do, and this is an easy fix, is you could just come into your blocky block guy and you could say, instead of 64 characters, you could say something like 32 or even 16, and that will just minimize the left and right randomness that we get. Let me try and hit that one. Perfect. All right, so we have particles in there. The final thing that we're going to be adding is going to be our sounds. So I'm going to import a sound, which you can grab from the Patreon page, and I'll just close it because we're not doing anything special with the sound. And I will close our script, and I will head back to the blocky block object. Now once we've hit the floor, we've created a solid object, we've spawned the particles, the next thing that we want to do is play the sound. And this is going to be fairly simple. We'll say play sound, and we'll say audio underscore play sound, and the sound is SND hit, which we actually need to give it the proper name, so we'll say SND hit. So we'll play that sound. The priority we'll just say is 2, and it does not loop. And with that, we should be able to play our game. And as long as I'm recording the audio on my computer, we should see some sound effects here. I'll turn up my volume. Perfect. I'm not sure if you can hear that, but I'll include a demo that you guys can download. And that is actually it. So now we have full animation. We have our enemy throwing us back once we get hit. We have some dust particles and we cannot walk through them. Maybe one of the mechanics we'll have is you have to jump on top of them to get over something, I'm not sure. But I would say that this enemy is now fully finished and we can move on to something else. I'd like to give a huge shout out to my anonymous patrons and also Matt and Paul for supporting me. If you like this video, please leave a like or a comment below. Otherwise, hopefully you'll like it enough to subscribe to the channel. Once again, this is Mickey and I'd like to thank you for watching.